A baseball player swings and hits a pop fly straight up into the air to the catcher. The height of the baseball in meters t seconds after it's hit is given by the quadratic function. H of t equals negative 4.9 t squared plus 14.7 t plus 1. How long does it take for the baseball to reach its maximum height? What is the maximum height obtained by the baseball? So the function that we're given, h of t, equals negative 4.9 t squared plus 14.7 t plus 1, is going to tell us the height, so h stands for height, at any moment in time after the ball is hit. So if we choose a t, choose a time, and substitute it in for these t's here, that will tell us the height at that moment. Now what this question is asking for is something very specific. They want to know the time, how long. They want to know the time it takes to reach the maximum height and what is that maximum height. So we use that word maximum, and that maximum is the highest, in this case, highest height, the highest y value. Now, in this example, we were given a quadratic function, and we know what the graph of quadratic functions look like. They're either a parabola that opens up like this, or a parabola that opens down. We already know which one it is for this example by taking a look at the a, which is attached to the squared term. The negative 4.9 is the value of a. What I'm referring to is most quadratic functions can be written, or all quadratic functions can be written in this format: ax squared plus bx plus c equals 0. A is the coefficient of the squared term. And so our example, we have a equals negative 4.9. Anytime a is negative, we know that we have a parabola that opens down like this. So a being negative 4.9, which is less than 0, means that we have a parabola that opens down. And looking at that picture, if we have a parabola that opens down, remember, we're looking for the maximum height. The maximum height is going to occur at the vertex. So I'm going to be able to answer the question that's asked: how long does it take the ball to reach the maximum height, and what is that maximum height, by finding the vertex of this parabola. So we do have a formula for finding the vertex called the Vertex Formula. And our vertex is usually written as an ordered pair, HK. And the formula is for the x-coordinate of the vertex. That's negative b over 2a. So you can see it's using the a and the b. The a is the coefficient of the squared term, and b is the coefficient of the x term. Once we get the value of h, the x-coordinate of the vertex, we can find k, the y-coordinate of the vertex, by plugging h into the function. So we're going to substitute this negative b over 2a into the function to get the y value of the vertex. So for our example, we're going to find h, which is negative b over 2a. That's negative 14.7 over 2 times negative 4.9. I've got my calculator here. So 2 times negative 4.9. That'll be negative 9.8. So 14.7 divided by 9.8 is positive 1.5. And that's going to be the x-coordinate of the vertex. Then I'm going to get the y-coordinate of the vertex by substituting 1.5 into the function. So I'm substituting into the height function 1.5. That's negative 4.9 times 1.5 squared plus 14.7 times 1.5 plus 1. So I need to do 1.5 squared. That's 2.25. 14.7 times 1.5 will give me 22.05. And 2.25 times 4.9 will be a negative 11.025 plus 22.05 plus 1. I'm going to add negative 11.025 plus 22.05, and that's going to give me 11.025 plus 1 is 12.025. So that is now our vertex. Our vertex is 1.5 and 12.025. So we want to make sure we know what these values mean. So ordered pairs are typically x and y values. In this example, x and y weren't used. We have t and h. So t is our x, our independent variable, and h is our y, our dependent variable. And so this 1.5 is referring to the time, and the 12.025 is referring to the height. So in this example, that baseball is going to reach a max height of 12.025 meters at a time of 1.5 seconds. So if I go back to these questions that were asked here, this first question, how long does it take for the baseball to reach its maximum height? It's going to reach its maximum height at 1.5 seconds. And what is the maximum height? That maximum height is 12.025 meters. So I want to ask the question, f of x is greater than 0. Okay. So we know that f of x is y. So essentially, when it says f of x is greater than 0, we're saying y is greater than 0. So on our y scale, y is greater than 0 when we're above the x-axis, y is less than 0 when we're below the x-axis, and y is equal to 0 when we're on the x-axis. So to answer this question of f of x being greater than 0, we want this piece of the graph that is above the x-axis and this piece of the graph that is above the x-axis. So what are the matching x values? The matching x values are from -infinity to -2 and to infinity. So the answer to our question is that y is greater than 0, or f of x is greater than 0 when x is from -infinity to -2 and, oh, sorry, I messed that up. This is not 2 right here, this is a 3. So when x is from -infinity to 2 or 3 to infinity, that's when we get y values that are greater than 0. Okay, so I'm going to add this part in. So what if I adjusted the question to say f of x is greater than or equal to 0? So the only thing that's different about this is that equal to. So now what we want to do is we want to include these points that are on the x-axis. So we would say -infinity to -2 with a bracket 3 to infinity. So this now includes the parts that give us a y that is greater than 0 and the parts where y is equal to 0. So if I were to give you this, f of x is less than 0, now we're looking for the parts where the graph is below the x-axis, and that would be from -2 to 3. And then if I changed it to less than or equal to, I would want to include the -2 and 3. Solve the following inequality. X squared plus 3x is greater than 10. Now this particular inequality is a quadratic inequality because of the squared, and we have a process that we go through for solving these types of inequalities. The process starts with us treating this inequality instead like an equation. So I'm going to change that greater than symbol to an equal to and move all the terms to the same side and solve. So I have x squared plus 3x minus 10. We can factor this into x and x. 5 times 2 is 10, a plus on the 5, a minus on the 2. I can set each factor equal to 0 using the zero product property and get x equals -5 and x equals 2. I'm going to take those values and put them on the number line. I'm going to mark them out in order, -5 and 2. Now since my inequality is a greater than, I'm going to mark those numbers on the number line with an open circle, because those values will make this expression equal to 0, And we're looking for it to be greater than 0. So we're actually going to rewrite this as well. X squared plus 3x minus 10 is greater than 0. So we're looking for when this expression is greater than 0, and these two values that we came up with make the expression equal 0. So we're not going to include them in our solution set. Well, now what we need to go do is test each one of these intervals to see which one of those intervals will make our inequality true. So I'll choose a test point in each interval. I can use a test point of -6 in the leftmost interval, a test point of 0 in the middle interval, and a test point of 3 in the right interval. So I'm going to take those test points of -6, 0, and 3, and we're going to substitute them into the expression x squared plus 3x minus 10. And what we're looking for is whether the expression comes out to be positive or negative, because positive or negative is going to tell us whether it's greater than 0 or less than 0. So let's test these values. So for -6, we get -6 squared plus 3 times -6 minus 10, and that's 36 minus 18 minus 10. 36 minus 18 is 18, and 18 minus 10 is 8. So what we found is that in this interval, the leftmost interval, our expression is positive. Let's continue with the next test point. We have a test point of 0, and in our expression, that's 0 squared plus 3 times 0 minus 10, which works out to be -10. So in the middle interval, our expression is negative. With our final test point, we have 3 squared plus 3 times 3 minus 10. That's 9 plus 9 minus 10. 18 minus 10 is 8. So in that leftmost interval, our expression is positive. So with our inequality, we want our expression to be greater than 0, and that would be our positive intervals here. So the intervals that make this inequality true are the leftmost interval from -infinity to -5. I used a parenthesis on the -5 to show that -5 is not included in the set. And then the rightmost interval is 2 to infinity. So the solution set for the inequality x squared plus 3x is greater than 10 is -infinity to -5 union with 2 to infinity. Okay, for this inequality, we need to do a little bit of work ahead of time. So for this whole thing to work, I need to have a 0. I need to have a 0 over here, because this is the part that's going to tell me what I'm looking for. If I'm looking for above the x-axis, below the x-axis, or on the x-axis. So I'm looking for, in this example, less than 0. The less than 0 part tells me I'm looking for below the x-axis, and the equal to part is telling me I'm looking for on the x-axis. So it's important for any polynomial inequality that you have like this to make sure that you have 0 on one side first. Okay, so once you do that, then you're going to find your on the x-axis part, the equal to part. We're going to set that equal to 0, and this can be factored into x plus 3 and x minus 3. That's a difference of squares. I get x equals negative 3 and x equals positive 3. And those are the values that I'm going to put on this scale here. And this time, since I want the values that are on the x-axis, I'm going to fill those in with dots instead of open circles. Then I'm going to choose my test points in each interval and pick -4, 0, and 4. And I want to test these in my inequality x squared minus 9. So I'm testing these x values of -4, 0, and 4 into x squared minus 9. -4 squared minus 9, 16 minus 9, that's a positive, so this interval is positive. 0 squared minus 9 is -9, that's negative, this interval is negative. Negative or below the x-axis. 4 squared minus 9, 16 minus 9, that's positive. So this last interval is positive or above the x-axis. Now we wanted below the x-axis and on the x-axis. So for our problem, we're going to use this one in the middle. That gives me all the values below, and I'm going to include the endpoints, which gives me the ones that are on the x-axis. So I'm going to have -3 to 3. All the x values from -3 to 3 give me y values that are below or on the x-axis. So you might be given an inequality like this one here. X squared minus 3x minus 4 is greater than 0. So what we're going to do, we're treating this as this right here as my f of x. And we want to figure out when it's greater than 0. Now, I don't want to draw the whole graph to be able to figure out this answer. So here's what I'm going to do. I'm going to take my function, x squared minus 3x minus 4, and I'm going to set it equal to 0 so that I can find those x-intercepts. And I'll factor this. I get x and x, 4 and 1 with a minus and a plus. Set each factor equal to 0. That gives me x equals 4 and x equals -1. And I drew this number line over here because I'm going to mark on the number line those two values, -1 and 4. And I'm going to mark them on the number line with open circles. Open circles because we don't want those. Our example here is only greater than 0, not equal to 0. Equal to 0 would be those x-intercepts. We don't want them. So then what I'm going to do is I'm going to test in each one of these intervals whether the graph is above or below. Positive would be above, negative would be below. So I'm going to choose a test point in this interval. I need to choose a test point that is less than -1. So I'll choose a test point of -2. I need to choose a test point in this interval, something in between -1 and 4. I'll choose 0. I'll choose a test point in this interval, something greater than 4, like 5. And I'm testing these values in my quadratic. So let me test each one of them. I'm testing an x of -2, 0, and 5, and I'm testing them in my quadratic. That's -2 squared minus 3 times -2 minus 4. That comes out to be 4 plus 6 minus 4. 10 minus 4 is 6. And that came out positive. So this interval is positive or above the x-axis. Then I'll test 0. 0 squared minus 3 times 0 minus 4 comes out to be a -4. That's negative. So this interval is negative or below the x-axis. The last one, 5 squared minus 3 times 5 minus 4. That's 25 minus 15 minus 4. 10 minus 4 is 6. That's positive. So this interval is positive or above the x-axis. Now we want greater than 0. We want above the x-axis. So we're going to use these intervals as our answers. Those intervals are -infinity to -1 union with 4 to infinity. So this is the solution to the inequality. Thank you for checking out my videos. Have a great day.